All right, so we are gonna start our lesson on rewriting expressions in factored form. So what I'd like for you to do is calculate this product mentally. So 9 times 11. And what I do is actually just multiply that. I know that fact is 99. You could also break that up and go 9 times 10 is 90, plus 9 times 1 is 9, and 90 plus 9 is 91. So what I want for you to do is now multiply 19 times 21. So what I do is 19 times 20. So I do 19 times 2, which is 38, and then add a 0, so 380. And then 19 times 1 is plus 19. So 380 plus 19 is 399. Then here, 19 times 101. I do 19 times 100, which is, or I'm sorry, 99 times 100, which then gives me 9,990. And then multiply 99 times 1. So I add 99 to that, and I get 9,990 plus the 99 gives me 99. Or 9,900 plus the 99. And then 109 times 101. I do struggle with that one a little bit mentally, but I will write down the answer for those that can do that a little bit more mentally. I would actually reach for a calculator or write that down with paper. So we're going to move on to our task. We'll look at the first task. Claire claims that 10 plus 3 times 10 minus 3 is equivalent to 10 squared minus 3 squared. And that 20 plus 1 times 20 minus 1 is equivalent to 20 squared minus 1 squared. Do you agree or disagree? Show your reasoning. So for number 1, I'm going to write 10 plus 3 times 10 minus 3. And I'm going to expand that. So 10 times 10 is going to give me 10 squared. And then 10 times negative 3, I'm just going to put that and put minus 3 times 10. And then plus, and then 3 times 10. So plus 3 times 10. And then I'm going to subtract 3 times 3, so minus 3 squared. So I notice I have adding 3 times 10 and subtracting 3 times 10, so those are going to cancel out. So that is going to give me 10 squared minus 3 squared. I'm going to try the same thing with 20 plus 1 times 20 minus 1. And multiplying that out, 20 times 20 is in fact 20 squared. 20 times negative 1, I'm going to put minus 1 times 20. And then plus 1 times 20. I notice that these are opposites, so I'm going to cancel them out. And then positive 1 times negative 1 would be minus 1 squared. So 20 squared minus 1 squared. And it looks like we would agree with Claire, and here's our reason. So we can write down Claire is correct. So now use our observations to find 100 plus 5 times 100 minus 5. Show your reasonings. So it looks like I'm just going to multiply 100 times 100. So 100 plus 5 times 100 minus 5. I'm going to square 100, so that's going to give me 100 squared. And then I'm going to subtract 5 times 5, or 5 squared. And then 100 times 100. I know that when I multiply 100 times 100, I take 100 and then add 2 zeros. And then I know that 5 squared is 25, so I'm going to subtract 25. And then that would give me 9,975. So part B, if I compute 105 times 95, it is, in fact, 9,975. So now here with a diagram, if I have x plus 4 times x minus 4, is it equal to x squared minus 4 squared? So I'm going to fill in the boxes a little bit better there. And I have x times x is x squared. 4 times x is 4x. Negative 4 times x is minus 4x. And negative 4 times 4 is negative, and then 4 squared. So in multiplying, or in simplifying that, we had x squared plus 4x minus 4x, and then minus 4 squared. Those are going to cancel out, and it would give me x squared minus 4 squared. And then without a diagram, we could do x plus 4 times x minus 4, and then use that with distribution. So x times x gives me x squared. X times negative 4 would be minus 4x. 4 times x would be plus 4x. And then minus 4 times 4 would be minus 4 squared. Crossing that out, I would get x squared minus 4 squared. So either way, that is correct. And we supported our answer with the diagram and without a diagram. So now the question is x plus 4 squared equivalent to x squared plus 4 squared? It is very tempting to just apply the square there and say x squared and then plus 4 squared. But I know if I write that out, x plus 4 squared is equal to, with a diagram, I'm going to write that in factored form. So I have x and 4 and x and 4. And that would be x squared. Here I would get 4x, another 4x. And then here I'm going to write 4 squared. So in combining all my terms, I would get x squared. When I add 4x and 4x, I would add and get 8x. And then plus my 4 squared, or 16. So this x plus 4 squared is not equal to x squared plus 4 squared. So x plus 4 squared is equal to x squared plus 8x. And I'm going to simplify 4 squared. 4 squared is 4 times 4, or 16. So now what we're going to do is complete this. So I know if I multiply x minus 10 times x plus 10, I square the first term, so x times x is going to make x squared. And then I'm going to subtract 10 times 10. So I'm just going to put minus 100. Same thing here. I have 2x plus 1 times 2x minus 1. So I would multiply 2x times 2x, Or I could write in parentheses, that first term is 2x squared. And then I would minus 1 squared. But 2x squared, 2x times 2x, I could simplify that further into 4x squared and then minus 1. Same idea here if I have 4 minus x times 4 plus x. 4 times 4 would give me 4 squared. And then negative x plus x, I would put minus x squared. So 4 squared is 16, and then minus x squared. And then I notice here, if I have x squared minus 81, 81 is a perfect square. If I take the square root of 81, that gives me 9. So I know that I could kind of work backwards here and say, well, this is going to be x and x for the first term. And then I add 9 and subtract 9. Same idea here. The square root of 49 is 7 because 7 times 7 is 49. So I could write that as 7 and 7. And then here, if I'm minusing y squared, I could add y and then subtract y. Now 3z squared, I actually need to take the square root of both pieces. So to make 9z squared, I'm sorry, I misspoke. But I would multiply 3z times 3z. So my first term is going to be 3z and then 3z. And then to make the minus 16, I know I could add 4 and subtract 4. Same idea for 25t squared. I could multiply 5t times 5t. And then I could add 9 and subtract 9. And then here, if I'm multiplying, I could go c times c is c squared. And then if I do a plus minus, I know that I'm going to minus. And then I need to square 2/5, so I could write this as 2/5, the fraction, squared. Or I could simplify that and write c squared minus 2 times 2 is 4 in the numerator, and 5 times 5 is 25 in the denominator. Same idea here, 49 over 16. I know that 49 is 7 in the numerator, so 7 times 7 would make my 49. And in the denominator, I could have 4 and 4. And then if I'm minusing d squared, I could add d for the second term and then subtract d. For x plus 5 squared, it looks like I would have x times x is x squared. X times 5 would be 5x. So plus 5x. And then plus another 5x. And then plus 5 times 5 is plus 25. I'm going to simplify that underneath it and combine my like terms. 5x plus 5x is 10x. So x squared plus 10x plus 25. And then if I did x squared minus 100, I know that I could have x times x. And then since I'm minusing a number, I'm going to have a plus minus. But if I need two numbers that multiply to be 6, what I would do is take the square root to figure out what that is. So I would have x plus the square root of 6 times x minus the square root of 6. And then as I look at this, I don't have an x term, but I have positive 100. So to break this up into factors like that, that is not possible.